Okay, so these are the solutions to questions 12 and 13 of the magnetic fields homework booklet. So in question 12, what we have is we've got some charged particles. Each of these charged particles have a mass of m and a charge of q, and they're all travelling at a constant speed in a circle, and the circle has a radius of r. Associated with this is a uniform magnetic field, and that has a flux density of B. So we want to know which expression gives the frequency of rotation of a particle in the beam. So basically these particles are going round and round in a circle, and what we want to know is how many times per second they go round in a circle. So what I'm going to do is I'm going to work out the time period, because if I know the time period I can work out the frequency. So we're going to start off with our bog standard kind of link between the force and the centripetal force. So this is our equation for centripetal force. Because it's a charged particle in a magnetic field, this is the force on the particle, and they're equal to each other. So I can calculate the velocity, which is equal to BQR over m. Now, if I use speed as distance over time, the amount of time it takes to go round a circle once is equal to the circumference of the circle divided by the velocity. So the circumference of the circle is 2 pi r divided by the velocity that I've just worked out. So the velocity is this here, so if I divide by this number, that's the same as multiplying by the reciprocal of this number. So I've got 2 pi r times m over BQR. So if I simplify that, that's the time period of this particular oscillation. The frequency is simply 1 over t, so it's the reciprocal of this, and so therefore the frequency is BQ over 2 pi m, so our answer is A. Now in question number 13, we have a negatively charged particle and it's moving at right angles to the uniform magnetic field. We're asked to basically complete this sentence. So the magnetic force on the particle acts, is it A in the direction of the field, B in the opposite direction to that of the field, C at an angle between 0 and 90 degrees, or D at right angles to the field? Well, we know that magnetic fields, the particles in a magnetic field always go in a circle, which means that the force is always at right angles to the field. So therefore the answer straight away is D. So that was question number 12 and number 13 of the magnetic fields homework booklet.